Let's see the next question, which is question number 4. It says, what is the difference between a test case and a test scenario? This question can come in many forms. He can ask you like this about the difference between the test case and the test scenario. He can ask you about the definition of the test case and when do we write it and how do we write it. Also, he can ask about the definition of the test scenario and how it is written and when do we write it, okay? Another form of the question is to ask you about test analysis and test design. Those are two steps in the test process, and he might tell you, okay, what activities or which activities do we perform inside test analysis and which activities do we perform in test design, or which work products are produced in test analysis and test design. So if you studied the test process in a good way, you will know that in test analysis, we define our test scenarios or test conditions, and those are what are we going to test. In test design, we begin to identify how we are going to test those scenarios using test cases. So the first definition is the test scenario. The test scenario is any functionality that can be tested. It is also called a test condition or a test possibility. Many people get confused when they are asked about the difference between a test scenario and a test condition. Those are the same, okay? So for example, we have test the login functionality. So the login functionality, we want to test it. This is a test scenario or a test condition. We want to test the registration functionality. We want to test the checkout or adding item to cart. All of these are considered as test scenarios. On the other hand, the test case is a set of actions executed to verify a particular feature or functionality of your software application. So here the test case consists of actions, okay? Like we said here, or like we see, the test scenario is just one phrase or one sentence, but the test case mostly is a document. It contains some fields like steps, okay, the testing steps, those are the actions, like the expected result and the actual result, which is not filled until we execute the test case. So like we see here, a test case contains test steps, test data, preconditions, post conditions developed for a specific test scenario to verify any requirement. So for example, I have the login functionality, which is a test scenario. I will write many test cases for it. One of them might be test login with a valid username and a valid password. That's why we can say that the test scenario can be tested with more than one test case. Okay, we can have one test case for the scenario if it is a very simple scenario, but mostly one scenario will have more than one test case, 3 or 4 or even 10 or 20 test cases for one scenario only. Another tricky question in defining the test case is the actual result of the test case. Okay, so he might ask you, okay, there is a field in the test case which is the actual result, or he asks you to write a test case on a piece of paper, and you have a field that's called steps, expected result, actual result, and then you begin to write down the actual result. For example, login with a valid username and a valid password, and you write, okay, the actual result is login is successful and user is directed to the home page. This is very wrong, okay? Why? Because we are still designing our test cases. We didn't execute them on our software in order to know the actual result. So the field, the actual result field, you should leave it empty. Just write the name of the field and leave it empty. The same with the status. The status of the test case is new or ready to test. Don't say that this test case is passed or failed or blocked, because we didn't execute this test case yet. When you execute the test case, if the actual result is like the expected result, this test case is passed. If the actual result is different from the expected result, this test case is failed. If you are not able to execute the test case because, for example, it depends on another test case which has failed, in this case, this test case is blocked. If the test case is failed, we begin to write the defect report, and this defect report goes through the defect life cycle, which we explained in the previous question. Let's see the next question, and it says, what is the difference between functional and non-functional testing? This question also can come in another form, which is, what are the main types of testing? We have many types of testing like we explained earlier, but the main two types of testing are functional testing and non-functional testing. So first we have functional testing. This is the type of testing which verifies that each function of the software application operates in conformance with the requirements specification. So we have functions inside our system or inside our SRS or inside our backlog or user stories. We begin to test them in order to make sure that they are working like what is stated inside the requirements document. Functional testing tests what the system does. Does the system perform the intended functions in a correct way or not? On the other hand, non-functional testing is a type of testing to check non-functional aspects. So we have non-functional requirements in our requirements document like performance, usability, reliability, and security. Non-functional testing tries to test those functions, and it tests how well the system performs. So for example, like we see here in functional testing, we might test the login functionality. Does it work like expected or not? Okay, when I enter a valid username and a valid password, am I redirected to my profile page or not? On the other hand, in non-functional testing, we might test the performance of the system when 100 users log in simultaneously. This is performance testing. We might also test the login functionality from the user interface or the user experience while he is going through the login scenario, okay? In this case, this is usability testing. We might also perform something that's called SQL injection in order to make sure that the login form is secure or not. This is also non-functional testing. Functional testing mostly can be answered with yes or no. So you as a tester might be asked by the stakeholders, okay, is the login functionality working or not? In this case, you say yes if it works, no if it doesn't work. On the other hand, mostly non-functional testing cannot be answered with yes or no, okay? Most of its answers can be identified on a range of numbers. So for example, if I ask you, is the login functionality fast? You cannot say yes or no, but you can tell me that you have tested this functionality using 100 simultaneous users, and in this case, the response time of the system was 3 seconds. So this is performance testing. Those 3 seconds can be a good performance in some systems, and in other systems like brakes in cars, for example, this is a very bad performance, or in gaming. That's why it is very hard to answer with yes or no on non-functional requirements. Of course, we have other types of software testing, but if you are asked about the types of testing, the first answer is functional testing and non-functional testing. After that, you can tell the interviewer about other types of testing, like structural testing or change-related testing, for example. But first, you must begin by identifying functional and non-functional testing. Another popular question is, what is the difference between validation and verification? When we talk about validation, we say that we built the right product, okay? So the customer asked us about a specific product, okay, a specific software. Did we build it in a way that satisfies his requirements? Will the customer be happy by using this software or not? On the other hand, when we talk about verification, so we are talking about, did we build the product right? Did we build this product in a correct way or not? So let's think of our course, for example, as a product. If someone who doesn't know anything about software testing comes to this course and begins to study. If we talk about validation, so validation means, is this trainee happy with the content of the course or not? So how can we satisfy the requirements of the trainee? Okay, the videos should be of good quality, the voice should be clear, you should also have quizzes on each section, the explanation of the concepts should be very easy, and we should have practical exercises on each section, okay? So this is validation. But this person who is going to enter the field for the first time, does he know what is required from him in order to work as a software tester? No. So if there is, for example, a section that is missed from the course, he might not have enough knowledge to know that he should study this section, okay? This is the same in our systems. So for example, in validation in our software, the customer might be very happy with the software, but it is also a bad software. We showed him the software, it is working very well, but what happens if 10,000 users access the system in the same time? Okay, here comes verification. What if a hacker tries to hack the system and access some data of the users? The client or the user is not able to know is this requirement satisfied or not. So this is verification. Did we build it in a good way or not? So like we see here in validation, we validate the end product like developed software or service or system. It cares about the customer point of view. It is validated by the executing the software. We need to execute the software in order to know is it valid or not. We can use functional testing, system testing, smoke testing, regression testing, and many other types of testing. On the other hand, in verification, we verify the work products like the requirements, the design, the ER diagrams, entity relationship diagrams, the test plan, and the traceability matrix. It thinks of the software from the developer point of view. It is verified without executing the code. So if we are performing a review on the code or static analysis, this could be verification. It can use some techniques like informal review, inspection, walkthrough, technical, and peer review. So what are those techniques? Those are review techniques that are explained in the ISTQB foundation level. So he means that mostly verification uses static testing techniques, but not all the time, but most of the times.